Hello, everybody. This is your notes and examples video for trigonometry, right? This video is going to be a little bit longer because I'm putting all of trigonometry, like all the trigonometry notes and examples into one video here. So we'll have lots of examples a little later in the video. And then obviously, if you want to look at more examples and do more practice problems, you can look at the practice problems video. All right, you guys, so let's go ahead and jump into it here. As always, the notes that I normally would give you in class are on the left side of the screen, and your student notes are on the right side of the screen. Okay, so let's talk about trig. So up to this point, when we've been talking about triangles and right triangles, we have lots of tools that we've looked at and learned, right? We've looked at geometric mean and similarity in order to figure out side lengths. We've looked at Pythagorean theorem, the converse of the Pythagorean theorem. We've looked at and used the triangle sum theorem, which is all the angles in a triangle have to add up to 180. But the one thing that we haven't had yet up to this point is a relationship or a formula or something that we could use to tell us a relationship between the sides and angles in a triangle, and specifically for us in a right triangle. You can use trig for other types of triangles, but that's like an algebra 2 type skill. If you're interested in learning about that, let me know, and I can show you a little bit about how we use these tools with triangles that are not right triangles. But for us, for right now, we are going to look at how we use trig with right triangles, okay? So a trigonomic ratio is the ratio or a fraction, right, between the lengths of two sides in a right triangle, okay? And we calculate that ratio using one of the angles in the triangle. Okay, so what trig relationships do is they give us a relationship between the angles and the side lengths. Okay, which again is not something we've had up to this point. All of the other tools have either dealt exclusively with sides or exclusively with angles. Okay, there are three basic trig ratios. Okay, that we're going to look at in this course. There are three others, but we are going to focus on the three main ones, which are sine, cosine, and tangent. They are abbreviated using the first three letters of each word. Okay, so sine is abbreviated SIN, cosine is abbreviated COS, and tangent is abbreviated TAN. Okay, and there are three basic formulas or relationships that are always true. One for sine, one for cosine, and one for tangent. Okay, so these are your three ratios. Okay, so sine is always the opposite leg of an angle that you're looking at divided by the length of the hypotenuse. Okay, so opposite, if I could spell, that would be awesome. Opposite over hypotenuse. And I'm going to fill these. Right now, they don't look like formulas on your guys' notes side because I have to type them first and then add all the other stuff in. Okay, cosine is adjacent leg divided by hypotenuse. And then tangent is the only combination of opposite, adjacent, and hypotenuse that we haven't had yet, which is opposite over adjacent. Okay, so give me just one sec to draw these fractions in here. Hold on. Okay. Right, so there you go, sine, cosine, and tangent. Okay, these can be a little bit tricky for people to remember. Okay, and the way that we usually remember them is we use this acronym, SOHCAHTOA, SOHCAHTOA. CAHTOA. It helps us remember which side lengths go with which trig function, okay? And you'll see me write it very often with something that I call my fraction version. So if you look on the right side of your screen right now, you'll see me often write it this way with a big capital S, OH, so, ka, toa, okay? You see me write it this way because one, it has all of the benefits of the acronym, right? Tells you S for sine, and C for cosine, T for tangent, but it also writes the legs as an actual fraction. So you know which value should go in the numerator and which value should go in the denominator. Okay, remember what these three basic trig formulas give us is they're going to give us a fraction, a ratio, a decimal value, right? Which is the relationship between two sides in a right triangle, okay? Right? The sine, cosine, and tangent parts are typically attached to an angle, right? And then when you plug those things into your calculator, what the result is, what the calculator will give you is this exact ratio, right? Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, depending on which trig function you are looking at. Okay, so again, we use this in order to, one, give us a relationship between an angle measurement and the side lengths in a triangle, in a right triangle specifically. Okay, whoops, I went too far on this side, apologies. Okay, and also it can be used to then solve for missing values in a right triangle that we may not have had up to this point. Okay, so typically, and you don't have this on your screen or on your notes page, but I'm going to do an example for you a little bit later in the video that has these kind of formulas in it. Okay, so sorry everybody, video got paused there for just a second. So these three ratios that you see, the sine, cosine, and tangent, the one thing that's missing is the angle, right? Because you have the trig function and then you have the side lengths, but we don't have the angle anywhere. So normally, the way that these formulas are written looks something like this, where you have sine, cosine, or tangent of an angle equals whatever your fraction is. Okay, this part right here, whoops, let me change my color here. This part right here is something that you plug into your calculator. It's just a number. Okay, often it's a number with a lot of decimal places, but it is just a number. Okay, and it's a number that's equal to whatever this fraction is equal to on the right-hand side. Okay, so this is the typical equation that we use, okay, when we are trying to find a missing side length using trigonometry in a right triangle, okay? But you can also use trigonometry in order to find a missing angle, right? Say you have a right triangle and you only know the 90-degree angle and you don't know the other two. If you know some side lengths, you can use inverse trigonometry to figure out what the missing angle is. Okay, so in just a sec, I'm going to pause this, clear my screen, and go to the next slide here, and we're going to talk about inverse trig really quickly. Okay, so inverse trigonometry is essentially the same relationships, except instead of using your angle measurement and the trig function to find a missing side, you're going to use your side lengths with the corresponding trig function to find a missing angle. Okay, so as you, I'm hoping, recall, because it was like maybe 2 minutes ago, uh, when I did this for you in the video, right? With regular trig, okay, with regular trig, you'll have the trig function. The angle will go inside the parentheses, and it will equal the fraction on the other side. Okay, and I'm using sine for most of my examples just because it's the first one, but you can use cosine and tangent here as well, as long as you put the right fraction over on the other side of the equal sign. Okay, in inverse trig, all you do is switch the angle and the fraction. Okay, so we know inverse using a superscript little -1 to mean like opposite. You guys may remember doing that in your algebra classes, where if you were trying to find an inverse function, remember you would take the x value and the y value, say in like an equation of a line, you would switch them and then resolve the equation for y. Okay, this is a very similar thing where all we're doing is switching the fraction and the angle. Okay, so basically just doing the trig in reverse. Okay, now the cool thing about trig, just in general, is as long as you know what the relationships are and you set the relationships up correctly, the hard part, which is the actual like trigonometry, right? So like figuring out what this number is or figuring out what this number is, the calculator will do that for you, okay? Mathematicians who figured out these trig ratios were able to figure out exactly what the ratios will be of the side lengths in a right triangle for basically every possible angle measurement that you can think of, right? And then when we created calculators and computers, we were able to program our calculators and computers to do all of that hard work for us rather than having to look at a bunch of tables and all of this crazy stuff, right? So the hard part, which I have listed in like underlined here in pink for you, this is done in the calculator, right? It's always just a number and you find with your calculator. Okay? So you may be thinking about this right now and looking at it and being like, I'm not exactly sure what this looks like in practice. Like, how do you actually solve problems like this? I am going to do some more, lots of examples for you a little later in the video. Okay. So give me 1 second. I need to clear my screen off and we're going to talk about briefly the steps that you usually go through to solve triangles with trig. And then I'm going to do lots of examples for you so you can see how these problems are done. So I'll be back in just a moment. All right, folks. So here are your steps for solving a triangle, okay? Any triangle using trigonometry, okay? So often the problems will look something like this, okay? Where you'll have an angle that they give you, one side length, and then they're not going to give you any other side lengths. Like they'll give you two things. They'll either give you two sides or an angle and a side. Okay, and you have to use those pieces of information in order to find your missing values. Okay, so here are the steps that you follow. Okay, this is just one example. Like I said, I'm going to do lots of examples for you a little later in the video. Okay, so your first step is to pick an angle in the triangle and circle it, okay? Meaning not the right angle, but one of the others, okay? And you should pick the angle that's going to help you the most, meaning don't do a bunch of extra work. So in this picture, the angle that I should choose is C because I have a number. I have an actual value for C. I either have a number or a variable there, okay? Step 2 is to figure out where that angle's opposite and adjacent sides are in the triangle. Okay, so remember when I was talking about all these trig ratios that we have, they're all dealing with opposite and adjacent sides. Okay, so if you recall from most of these other times when we've been dealing with triangles and we've talked about the opposite of something, right? It's always the side that is farthest away. Okay. So typically, I have people pick out that side first, right? So circle your angle. If it's a little difficult for you to visualize where the opposite side is, a good trick is you can, from your circle, draw an arrow all the way across the triangle. Whichever side it hits, that is your opposite side. So what I'm going to do is put a big O right there. Okay. Next, I usually have people pick out the hypotenuse. The hypotenuse is always the longest side and it's always opposite or across from the right angle. Okay, so in this triangle, it's 15. Right? So I'm going to put a big H there. Then whatever side you have left is your adjacent side. So I'm going to put an A there. I can tell this is the adjacent side because it's not the hypotenuse and it's right next to my angle. Okay? So now that I have my triangle labeled, okay, so I've done step 1 and I've done step 2. Okay. Step 3 is use the sides given in the problem to choose the correct trig function. So I need to look at the information that was given to me and I say, okay, I have nothing for A. So that's not going to help me, but I do have something for O, even though it's a variable, and I do have something for H. Okay. So if O and H are my sides, then that means I need to choose sine, right? Because remember, the acronym is SOHCAHTOA. Okay, and the trig function that goes with OH is sine. Okay, so that would be the correct trig function for this problem. Okay, I can check that one off. Step 4 says write an equation using the sides, the angle, and the trig function. Okay, so here I'm looking for a side, so I'm just going to use regular trig. Okay, so I'm going to put my trig function first, sine. Inside the parentheses goes the angle, which is 20, equals the fraction, which is opposite over hypotenuse. So opposite is x, and hypotenuse is 15. Okay? Once you get to this point, okay, you've done step 4, and you need to do step 5, which is just to solve for the variable. Okay? Remember that this right here, sine of 20, is just a number. Okay, and it's a number that you get from your calculator. So on most cell phone calculators, you're going to have to turn your calculator. And actually, give me a second. I'm going to turn the webcam on here so you guys can see me. There we go, and you can see my calculator here. Okay, I will move this so that you all can see the work that I'm doing in just a second. Okay, but so this is my cell phone calculator. Right? Very fanciful. Okay, typically, like most of you probably have phones like this, or maybe you have Androids, right? You have to turn it in order to get more options. And I know this is backwards. Let's see if I can get it to flip. There we go. Okay, so here, right, is my flipped calculator. And I know it's a little bit hard to see, but here, see there's these 3 buttons, SIN, COS, and TAN. Okay, those are your trig functions. Okay, so on your calculator, right, at least on mine, okay, I have to type the angle in first, like so. Okay, and then I have to click the correct trig button. So for this problem, I'm going to pick the sine button. Hold on. Sorry, guys, I'm doing this backwards. So I have to pick the sine button, which is this one, which is almost impossible for you guys to see, right? but it's there, SIN. So I'm going to click that button. And when I do, it gives me this crazy long decimal. Okay, so that number, 0.342, will replace sine of 20 in my equation. Okay, so let me turn the webcam off here so you guys can actually see what I'm writing. Okay, so sine of 20 here is that number that we got from the calculator. And I'm running out of space here, so I'm going to draw a little arrow and do this down at the bottom of the screen. So sine of 20 was just that decimal, 0.342. Okay. Typically, you can round to 3 decimal places because you're going to get a lot of decimal places. You can round to 3, and that's usually fine. Okay. So I have this 0.342 equals x over 15. Okay. Now, this just becomes a very simple, like one-step algebra equation that I need to solve, right? Okay, because the goal here is to get x by itself. So this is x divided by 15. So in order to cancel the 15 out, I have to multiply on both sides by 15, right? Whoops, hold on. So in my calculator, I'm going to do 15 times that decimal. Right? And when I do, I got 5.13 if you round. So that is the length of that side. Okay? All right, you guys. So I know I said at the beginning that I was going to do a bunch of examples for you in this video. I think actually I'm going to make a separate video for you that just has a bunch of examples so that I can make them really big on the screen for you and just kind of work through the examples in your notes page. All right. So that is just the basics of trig. Make sure you take a look at the next video because I'm going to do a lot of examples for you, very similar to this. And we'll do some word problems also so that you can see how to do trig with word problems. So I will see you all in the next video. Bye, everybody.